Today we are going to look at HCF and LCM. You have learnt about this in your previous grade. We'll try to revise what you learnt last year and also solve a few more questions so that you will be really good at solving HCF and LCM. Let's look at HCF. What is HCF? HCF is highest common factor. You also call it as GCD, greatest common divisor. How do you find HCF of given numbers? We've seen 3 methods last year, but we said there are only 2 methods that we use commonly. The first method is the prime factorization method, and the second method is the long division method. Let's try to solve using the first method, prime factorization method. Find the HCF of 80, 60 and 36. Remember, we are trying to solve this problem using the prime factorization method. So in this method, we have to find the prime factors of all the 3 numbers. Let's do that. 80, 2 40, 2 20s, 2 10s, 2 5s, 5 1s. Prime factors of 60, 2 30s, 2 15s, 2 15s, 3 5s, 5 1s. What are the prime factors of 36? 2 18s are 36, 2 9s are 18, 3 3s are 9, 3 1s are 3. So let's list it down. The prime factors of 80 are 2 into 2 into 2 into 2 into 5 into 1. In the same way, let's do it for 60. 2 into 2 into 3 into 5 into 1. And for 36, 2 into 2 into 3 into 3 into 1. So common factors. What are the common factors? We have 2 and we have another 2. These are the only 2 common factors. So the common factors are 2, 2. Therefore, HCF, highest common factor, will be 2 into 2, which is 4. This is your HCF. This is how you find HCF using the prime factorization method. Let's look at the second method, long division. Let's find the HCF using long division. We are taking the same numbers, 80, 60 and 36. In this method, the first step is to divide any 2 numbers. So we divide these 2 numbers, 80 divided by 60. 61s are 60. If you remove that, 20. Remember, we bring 60 all the way here. And the remainder becomes the dividend. 20 goes 3 times 60. That's it. This is your first step. So HCF of 80 and 60 is 20. Now in step 2, the third number that is remaining is divided with 60. So not 20, 20, 36. This is the HCF that we found earlier. Twenty ones are minus 16. The remainder becomes the divisor. The divisor becomes the dividend. 20 comes here. 16 ones are 16 minus 4. We continue this process till we get the remainder 0. So 16 is again brought here. Then 4 4s are 16. Remainder is 0. So therefore you need to take the last divisor, that is 4. Therefore the HCF of 80, 60, 36 is 4. This is how you are able to find the HCF using long division method. So when three numbers are given, step 1, you take two numbers and do the division. The last divisor becomes the HCF. You take the HCF and use that to divide 36. And then the last divisor that you get will be the HCF of all the three numbers. In this case, it is 4. Look at this question. Find the greatest number that divides 162, 322 and 482, leaving a remainder 2 in each. Find the greatest number that divides. So we know this is a HCF problem. So the step 1 is to subtract 2 from the numbers. We are subtracting 2 because in the question it's mentioned that it leaves a remainder 2 in each. So the first number is 162. Remove 2, you get 160. The second number given is 322. You remove 2, you get 320. The third number given is 482. You remove 2, you get 480. This is your step 1. You remove 2 from the numbers. The second step is to now find HCF of these three numbers: 160, 320 and 480. Let's do this using the long division method. So we will take 160 and 320 first. 160, 320 divided by 160 gives you, 160 goes 2 times, 320, 0. Therefore 160 is the HCF for 160 and 320. Now step 2 is where you take that, where you divide the last number 480 with 160. Goes 3 times, 480, 0. Therefore HCF of those three numbers is 160. This is how you get the 160, because you got the last divisor is 160. So I'm going over the steps once again. They asked us to find the greatest number that divides the three numbers 162, 322 and 482, leaving a remainder 2. Since they mentioned that a remainder 2 is left, we need to subtract 2 from all the three numbers. That's your step 1. You subtract 2. When you subtract 2, you get these numbers 160, 320 and 480. Now the step 2 is to find the greatest number that divides these numbers. In other words, you have to find the HCF of these three numbers, and using the long division method you get 160 as your HCF. So we found the HCF of 160, 320, 480 is 160. Tell you a couple of properties of HCF. Number 1, HCF of the given numbers cannot be greater than any of the given numbers. In other words, HCF will be equal to or less than the given number. For example, let's look at this 160, 320, 480. The HCF is 160. That means the HCF will always be less than or equal to the given numbers. That's your first property. We look at the other properties of HCF after we do LCM. Let's go and do LCM. You have learned two methods to find LCM. The first method is by prime factorization, and the second method is by division of prime factors. Let's look at each of these methods. Method 1, finding LCM by prime factorization method. Find LCM of 144, 180, 384. What is LCM? LCM we know is the least common multiple. So how do we find LCM using method 1, prime factorization method? We have to find the prime factors of each of these numbers. So 144, 2 72s are, 2 36s are, 2 18s are, 2 9s are, 3 3s are, 3 1s are, and the next number is 180. By now you should be good at doing divisions. 2 90s are, 2 45s are, 3 15s are, 3 5s are, 5 1s are. The next number is 384. We finished 144, 180, we're doing 384. 384 is 2 192s are, 2 96, 2 48, 2 24, 2 12, 2 6, 2 3, 3 1s are. There you go. Now I'm going to list down all the prime factors. 144 has how many 2's? 1 2 3 4 2's. So I write it as 2 to the power of 4. You remember the exponential form. And then it has got 2 3's, 3 square or 3 to the power of 2 and 1. How about 180? The prime factors are 2 2's and 2 3's. So that is 2 square into 3 square into 5 into 1. What about 384? It's got 1 2 3 4 5 6 7 2's. So it is 2 to the power of 7. And how many 3's? 1 3 and 1. Therefore, now we know how to do LCM. Remember, you have to take all factors but highest powers. This is how you take the LCM. All factors have to be considered, but the highest powers only. So what are the factors? We have 2, we have 3, and we have 5. What is the highest power of 2? If you notice, the highest power of 2 is 7. So we take 7, 2 to the power of 7. What about 3? What is the highest power of 3? Is 2, 3 to the power of 2. And what is the highest power of 5? Is only 1. So it is 5, just 5. Now you just have to solve this. 2 to the power of 7 is 128. 3 to the power of 2 is 9 into 5. This is 128 into 45. Therefore, your LCM is 5760. That's how you find LCM using the prime factorization method. Now let's do the second method, division by prime factors. Let's take the same numbers, 144, 180 and 384. In this method, we have to find the prime factors of all the three numbers simultaneously. So let's do it. 2, 72, 90, 192. 2, 36 245 is 90, 296 is 192. Let's take 2, 18 here 45 is not divisible by 2, so it is brought down as it is. 240 2 9s 45 again is brought down as it is because it is not divisible by 2. 224s 2 9 is also brought down as it is because it is not divisible by 2. Same with 45. 212s 2 9 is as it is, 45 is as it is, 6 2 9 45 3 is now we can do 3 is a common factor. 3 3 is 3 15s 3 1s 3 1s 3 5s the last one is 5 1s 1s 1. Therefore, LCM is, how many 2's are there? Let's see. 1, 2, 3, 4, 5, 6, 7. So we write it as 2 to the power of 7 into how many 3's? 1, 2. 3 to the power of 2 into 5. That is 5760. So using method 1 we got 5760. In method 2 also we get the same LCM, 5760. Here remember, we take the given numbers and we find the prime factors simultaneously. And when a number is not divisible by 2 or by the prime number given, you bring it down as it is. The LCM would be all the prime factors multiplied, and that is 5760. Now that you've seen both the methods, let's try to do this problem. Find the smallest number which, when divided by 20, 15 and 28, leaves a remainder of 9 in each case. The moment you see a question like this, you know that they're asking you for LCM, because they're asking you the smallest number that divides these three numbers. That is your least common multiple or lowest common multiple. But here they mention that it leaves a remainder of 9 in each case. So remember, so in HCF you removed the remainder from all the 3 numbers, but here you first find LCM and the answer would be LCM that you found here plus remainder. So let's find the LCM. How do we find the LCM of the 3 numbers 2, 15, 28? The commonly used method is the division by prime factors. So we are going to do that. 2, 10, 15 is brought down as it is, 14, 2 5s are 7s are 5, 1s are 3s are 7, 3, 7, 1, 1, 1. Therefore, what is the LCM? How many 2's are there? 1, 2 into 1, 3, 1, 5 and 1, 7. If you multiply this, you will get 4 into 105, that is 420. But remember, we have not yet got the answer because we need to add the remainder to this number. Therefore, the smallest number which divides 2015 and 28, leaving a remainder of 9, is this 420 plus the remainder, that is 420 plus 9, 429. That's your answer. Let's just check. 429 when divided by 15, 20 and 28, or 28, when you divide 429 by 15, 20 or 28, let's see what the remainder is. So let's just divide it by 15. 429 divided by 15. 15 2s are 30, 12, 9 comes down, 15 8s are 120. If you remove, the answer is 9. That is your remainder. This was just a check. So the answer to that question is 429. Here let's look at one property of LCM. LCM of 20, 15 and 28, we got it as 429, which leaves the remainder 9. Let's look at the property. LCM of given numbers cannot be less than any of the given numbers. In other words, LCM will be equal to or greater than given numbers. Look at the given numbers 20, 15 and 28. The LCM is always greater than or equal to given numbers. We saw earlier that HCF is always less than or equal to given numbers. So you got two properties of HCF and LCM. Let's look at another property. If the HCF of two numbers is equal to any one of the numbers, the LCM will be the other number. I'll show you an example. Let's take 12 and 48. If you have to find the HCF first, 48 by 12 will give you 4 12 4s are 48, 0. HCF is 12. HCF of these numbers is 12. So the property says if the HCF of two numbers is equal to one of the numbers, so we found that the HCF is 12, then LCM will be the other number. Let's see if LCM is 48. How do we find 12, 48? Let's do the division by prime factors. 2 6 are 12, 2 24, 2 3 12, 3 1s, we can do 2 2. Therefore LCM will be 2 to the power of 1 2 3 4 to the power of 4 into 1 3, that is 16 into 3, that is your 48. Therefore the two numbers given are 12 and 48. We got the HCF as 12. LCM, if HCF is one number, LCM will be the other number, 48. This is another interesting property of HCF and LCM. So here's the property. The LCM of two coprime numbers is always the product of the two numbers. Let's take 3 and 7. The HCF is 1 because they are coprime numbers. So if the HCF is 1, then LCM is product of these two numbers, that is 3 into 7, 21. Let's check. How do you find the LCM of 3 and 7? 3 1s are 3, 7 is brought down as it is, 7 1s are. Therefore LCM is equal to 3 into 7, that is 21. So for coprime numbers where the HCF is 1, the LCM will always be the product of the two numbers. That's your property. So here's a look at the properties of HCF and LCM we've learned so far. The first one is HCF will be equal to or less than the given number. Second one is LCM will be equal to or greater than the given numbers. The third one is if HCF of two numbers is equal to any one of the numbers, LCM will be the other number. We looked at the example of 12 and 48. And the last property we saw is that if HCF of two numbers is 1, that is if they are coprime numbers, the LCM of coprime numbers is always the product of those two numbers. Let's look at the relation between HCF and LCM. We're going to find something interesting. Let's take two numbers, 4 and 6. What is the LCM? If you do the LCM, you will find it as 12. And if you find the HCF, you will get it as 2. So I'll show you how you got this. 12, 4, 6 is 2 2s are, 2 3s are, 2 1s are, 3. So 2 into 2 into 3 is your 12, which is your LCM. How about HCF? 4, 6, 4 1s are is 4. If you do minus, you get 2. 4 is brought down here. 2 2s are 4, 0. Therefore HCF is your 2. So 4 and 6, you got HCF as 2 and LCM as 12. Now HCF into LCM is 2 into 12, that is 24. How about the product of the numbers given, 4 and 6? 4 into 6, 24. Therefore we see the product of LCM The product of HCF and LCM is the same as the product of the given numbers. That is an interesting property of HCF and LCM. The product of HCF and LCM of two numbers is equal to the product of the numbers. You can take any numbers, you will find those numbers satisfying this property. I hope this session has been useful to you. You can find this chapter in your textbook from page number 87 to 97. Go ahead and read the chapter and answer all the questions given there. That way, you will be really good at finding HCF and LCM. Happy learning. Bye-bye.